I think we're going to be able to get started. So first of all, welcome everybody. Good morning. I hope you all had a great time yesterday at Gillies. I know I had a lot of fun myself. So today we're going to see how we can create inspection control documents, inspection reports, and so on very quickly by leveraging your existing 3D data and model-based definition. So my name is Matt Forkade. I'm a product portfolio manager at SolidWorks. I've been with SolidWorks for almost 10 years now. I'm responsible for SolidWorks Inspection product line. I also work on some of the tools that we have for users, such as the new admin portal, online licensing, and our term licensing model. And today I will be talking again about SolidWorks Inspection, how you can leverage your SolidWorks 3D data with SolidWorks MBD. And I will try to show you all that in context, so how you can streamline all the way downstream to manufacturing. And I will use some of the content from my colleague, Obo Wu, who is the product manager for MBD. He's a great guy. He knows a lot about MBD, and he helped a lot of customers doing this transition as well. One of the other things I wanted to mention is, of course, if you have any questions, feel free to stop me. I'm going to do my best to answer the question that you have. And also, I always put my contact information on screen. I always bring business card because as product manager, we love to hear from you guys, how you work, what you like, what you don't like. That's how we get better. That's how we improve the product. And to be frank, that's how we came up with SolidWorks Inspection a few years ago. A few years ago, when we were meeting customers and talking to them, what we realized is a lot of them were creating inspection reports, but they were all doing it manually. It was taking them a lot of time. It was ended up being costly. It was just simply not the best way to do it. So when we go to customers and we see things like that, we try to figure out for them a better way, and that's why we came up with inspection since SolidWorks 2014. So it's not just for us about saving a pick and a click here and there. It's also about providing user perfect solutions so that you can easily go from design to manufacturing. So what we've seen in the past is normally the workflow we see is customer, we did a good job moving them from 2D to 3D. They design great product in 3D assemblies and make sure everything works and feed properly. They use all the tools inside SolidWorks to check for interferences, hole detection. And then they take that 3D data and they send it sometimes to other software to do visualization. But often they go back to doing a 2D drawing to do downstream manufacturing applications such as CNC machining, inspection reports, and so on. So what we're trying to do is eliminate all of those steps by giving you the ability to put more information directly on top of the 3D model, so you don't have multiple files to manage and things like that. And so that you can then leverage that 3D data to go directly to CNC machining, quality control, and so on. So let me start by covering how we can take that 3D data and add all the information that you will need for downstream manufacturing. And this is where SolidWorks MBD, which stands for model-based definition, comes into play. It's a drawingless application that lets you define, organize, and publish your product and manufacturing information. So that means your node, your GD&T, your hole callouts, your dimension, and so on. So you're going to be able to define all this directly in the 3D geometry. And with a SolidWorks MBD tool, you're going to be able to organize that in a comprehensive way, create 3D views, maybe show all the different stages needed to manufacture a particular part. And then you're going to be able to publish that in a format that is easily shareable with everybody in the company. So we, for example, support 3D PDF that pretty much anybody can open, even on an old machine. And you can even export all that to an e-drawing file with all the 3D views, a PMI, and all that. Now, the reason we started doing that is because, again, we talked to a customer, we realized that was a big hassle for them to do those 2D drawing and maintain those 2D drawing, even though we do a pretty good job with SolidWorks. But not only that, they were also spending a lot of time creating those drawings, but then communicating with people around the company, the design intent, answering questions about those 3D drawings and so on. So we saw that. We also validated those assumptions with surveys. That's what we surveyed a customer. We saw it was a lot of customers doing it that way. And then again, on the shop floors, I spent a lot of time trying to understand those 2D drawing, trying to do quality control document and so on. And obviously, 2D drawing can get pretty complicated. So we worked the last 4 years trying to put up a good solution so that you can pretty much do everything now in 3D that you used to do in your 2D drawing. And that includes things such as section view, breakout views, bend tables, and things like that. We're getting to the point where you can do almost all of that directly in the 3D model, and you can skip an entire step of your process entirely. So let's take a look at how this whole look in real life. So here I'm starting with a 3D model. And as you can see here, there's absolutely no feature, no dimension. It's actually a geometry that is just imported. At the bottom, I have a couple of what we call 3D views. Those are basically the equivalent of the views you have on a 2D drawing. And this is what's going to let me organize all the information I'm going to have to put on that 3D model. So all the different nodes, GD and stuff like that you normally have in a 2D view, I'm going to put in a 3D view, 3D geometry, and then organize everything in 3D view. So I have currently 2 views that I define at the bottom here. One where I'm going to have all my annotation, and one where I'm going to have just the nodes. The nodes that you normally have on a 2D drawing at the top left corner with basic manufacturing information. You can even do that in 3D. And if you're familiar with how 2D drawing works in SolidWorks, you can manually create a node, or you can standardize all of that, put those nodes in your design library, and then what you have to do is simply drag and drop it. So the same thing you do in 2D, you can now do it in 3D. You can drag that node inside the graphic area. You can edit that node. That node can be linked to custom properties. So I'm doing here, I'm adding a custom property. And so that it recalls automatically things such as, the mass, the material, things like that. So you can easily standardize all this within your company and speed up that part of the process. And I apologize, it's a little bit jiggerish. Not sure why it's happening with this laptop, but we're going to move forward anyway. So I put that node here, and I define in which 3D view I wanted that node to appear. And that way now I have a 3D view with all the annotation I'm going to add and just one for the node. That way I can keep things a little bit clean. Now moving forward, I need to add those nodes, those GD&Ts, those whole color and so on. And I can do that almost automatically by using our auto dimensioning scheme, where all you have to do is define if you want to automatically extract all the feature, or if you want to do it manually. So in this case, to kind of show you the whole workflow and all the things you can do, I'm doing it manually. I'm just picking a few features that I want the feature to automatically define. And since I want to use geometric tolerances, the first thing I do is I select a few datums. Primary, secondary, and tertiary datum. And then what I can do is pick a couple of features. So in this case, a couple of holes, those holes at the top. And in the bottom plane, since those 2 holes are exactly the same, the software automatically pick and recognize both of them, even though it's an imported part. Then hit OK, and as you can see, the software does a pretty good job at putting everything directly in 3D. So you have the diameters, the geometric tolerances, and so on, and he tried to do his best to put in the right orientation. Now you can always move those around, clean things up, rearrange stuff, moving into different plane if that makes sense. What is also nice is you have everything color-coded. So if you're familiar with SolidWorks, when you draw a sketch, blue is underdefined, black is fully defined. It's the same here. If it's in green, that means those features have been entirely defined. There's nothing left for you to do. If it's yellow, that still means you have information to add to the part, obviously, to fully define the whole geometry. So that's a very neat thing, and let you make sure you do your job properly. So again, I have a bunch of information already on the screen. One thing I wanted to mention is this thing that's pretty unique to SolidWorks is called dynamic annotation view. What we realized when we're working on this product is when you put everything on one part, it gets pretty messy quickly. You have a lot of things happening. So what this thing does is that it automatically ghosts or hides the annotation unless they are normal to the plane you're facing. So that way, even though you have a part that's very complicated with a lot of different things happening, you can still look at it, navigate through it, and it's still relatively clear. Now, of course, we have a feature tree at the left. We let you organize those PMIs. One of the things that's nice is you can quickly go through different views, reorient through those different views, make things everything is fine. And let's see in this case, if I have a geometric tolerances, I can even very quickly create basic dimension like we just did. I can also, relocate those. I can change the leader types and all that. So really similar to what you would do in a 2D drawing. Now the next thing is I'm going to add, more information here, more dimensions and so on. And I can use my size dimension tool to here quickly add a hole callout. It will automatically recognize all the holes in this part of the part. I can add a radius, a diameter, things like that. I can use this other tool to quickly define what the thickness of this plate is. And again, the software does a relatively good job at making sure you put all those annotation in the right plan. So I can keep doing that to kind of like give you an idea and define the entire geometry. Now, to be honest, even if it does a pretty good job, there's still some work left for you to do to make sure you reorganize everything, making sure nothing is interfering with each other, it looks nice for when you start creating your 3D PDF down the line. So here what I'm doing is just adding a few more for the example, and after that we'll see how we can take all that information and translate it directly into an inspection reports and other downstream manufacturing application. So I'm getting pretty close to the point where I have all the information I need. And what I can start doing now is go through the different view I have. And again, as I mentioned, reorganize things nicely. And once I'm done with this, I can create my 3D views will help me navigate through my design. So those 3D views that we saw at the beginning, I'm going to create a couple more of those. And they will be not only in the SolidWorks file for me to look at them, but I can also export them to a 3D PDF, an e-drawing file, and so on. And those 3D view will group things such as display states, configuration. You can define which annotation goes on those 3D views, the orientation on the part, and things like that. So if you have multiple configuration, maybe detailing the different step to manufacture that particular component, you could do that as well. You could have one file, one 3D file with all the different steps, and so on. So that's what I'm doing here. I'm creating a new 3D view. I'm giving it a name, picking a configuration. So again, here it's the final part configuration, defining which annotation are going to be visible in that particular 3D view. And then I'm just hitting OK, and it's adding one more at the bottom here. As you work on the parts, add more annotation. You can refresh those so that the thumbnail at the bottom will update. But just like that, you kind of build what a 2D drawing will look like. And what's nice is when you're done, you can quickly navigate through that. And the other great thing here is it's not a separate file that you have to manage. It's saved inside your 3D CAD file. So if you have data management things, that's one less thing you have to manage and worry about. It's all saved within the part. And again, that's just a very quick example of what you can do. So same thing here. I'm just cleaning things up. Making sure nothing is on top of each other, and then I'm going to create another view and to add to my project. Now again, those are just a few things you can do. You can, as I mentioned before, you can do pretty much everything you do in a 2D drawing today. We worked a lot in the last couple of years to add the missing pieces, but you can do notes, you can do tables, you can do surface finish, wall symbols, datum. You can do section views, breakout model views, exploded views too, which if you're working on an assembly, because this also work with an assembly, so you can do that as well. And again, when you're done with all this, you can then export that to a 3D PDF, an e-drawing file, a step 242, and so on. One of the things that I mentioned, because every time when I talk to customer, what I realize is a lot of people like the idea of drawing less. I think it's one of those things that makes sense for everybody, but it's obviously a big process to convert the company, and there's always that one vendor, that one department that need 2D drawings. So one of the things that we added over the last few years to make that process easier is we let you reuse the 3D views you create here. We let you reuse them in 2D. So let's say you want to move completely, but you still have that one or two cases where you need to create those 2D drawings. What you can do is create everything in 3D, do the whole thing we just done here, And if you have to create a 2D drawing, you can simply create a 2D drawing like you will do, but instead of dragging a view, adding dimension, doing things like that, you can simply drag your 3D view into the 2D drawing. So if you have to kind of do both for a while as you transition, that can also help you make this process easier. So basically here are the key benefits of MBD. It's integrated inside SolidWorks. Another application you have to jump to. It lets you define and organize a PMI. That's the main point. And what's great about this too is that it works with parts and assemblies. We have the 3D views that are really, really cool. Dynamic annotation view could be very useful if you have a lot of information on the part to kind of navigate through that. And as I mentioned, you can reuse those 3D views now in 2D drawings. Some of those things that we added in the latest release, we now support sheet metal parts with band tables, band annotation, and things like that. And we didn't see the 3D PDF export yet. We're going to show that soon. But those 3D PDF are customizable to an extent. So you have a template that we provide you, but there's a customization tool, so you can define what your company logo is, where a table is going to go, where the 3D views are going to go, and things like that. So you can kind of change the format a little bit. And one of the other things that is important is we support step 242. Now that's for MBD, and of course now that we're done with taking up parts and adding all that information directly onto the 3D model, the next step for us is to create our inspection report, which usually look like that: a 2D print with bubbles on it, and then an inspection sheet, often done in Excel. Now, what we've seen our customer do most of the time, again, is they will normally, either go on a 3D CAD software and add the balloons directly to the drawing, or actually even print the 2D drawing, add the balloon, then transpose all that on a Excel spreadsheet, fill in the nominal value, upper and lower limits, calculate all that, and they have to then do that for all the different views of their drawing. So of course it's a very time-consuming process. And then you have to add the extra information such as method of inspections, operations, criticality, acceptance quality limit, and all those kind of other things that take even more time. Here we have a video of my colleague, Steve, that's going through the high of doing this manually. And I think you get the point by now. Obviously, it's something that takes a lot of time. We see customers taking anywhere from 2 hours to 8 hours to do that. And what we're trying to do here is providing you a solution that you do this in a couple of minutes so you can spend your time on doing more interesting things. So basically, manual process, error prone, time consuming, and costly. In the case of my colleague here, it took him 55 minutes. So what we're doing here is we're taking our 3D parts, we take all the PMIs that we define the part, and we import all that directly into inspection. So let's see how that looks. I'm working with the same part. You can see I have all the information defined. I have all my views. I can quickly navigate through all those views, everything nice and neat. The next step for me will be to extract all that information and put it in a report. So I use SolidWorks Inspection. It's an add-in as well, so you run inside SolidWorks. You don't have to jump to a different application. And it's a very quick process. The first step is to pick a template. We let you create templates so you can say things such as what custom property to use, a balloon shape, default placement of the balloons, default tolerances, things like that, so that you don't have to redefine all this and you can kind of standardize things within the company. Then once you're done picking up the templates, the first step is to fill out the project properties. So, the part name, part number, things like that. And because you're in SolidWorks, you can always reuse custom properties, fill in the vendor name, the job numbers. You can even do some sampling and define the AQL right in there as well. I will take questions just in a second. Once you're done with all this, the next step is basically going through a checklist of what you want to extract from your 3D model. So here I have a list of all the different type of PMIs really that I can extract. Dimension, basic dimension, reference dimension, chamfer values, notes, do I want to explode the notes or not, GD&T, hole callouts, and so on. I just pick and choose what I want. And then the software will take a minute or two and automatically goes through the entire part, extract all the information, and add the bubbles directly in the 3D geometry, in the 3D view. So on the left, I have my what we call characteristic tree, which is basically a preview of the inspection report that I'm building with all the different information. You can see that, if you have, let's say, diameter with a quantity of 4, I selected the option that automatically let me add multiple lines in my report for that, because the inspector is going to have to, in that case, inspect all those different holes separately. And then basically all the information you have in a report you can fill out here. That includes comments, that includes classification, method of inspection, AQL, things like that. If you were to, let's say, change the tolerance because you need to have a different tolerance for that particular characteristic, you can do that here as well, and it will not change the 3D model or the information of the 3D model. It will just be for the purpose of the report. You can make any characteristic a key characteristic, and we saw that on screen where I define a different balloon shape for a key characteristic. I can remove some of those annotations if I didn't want them in my report, and I can customize the balloon, change the balloon shape, change the balloon colors, all those kind of different things. And now that I'm going through the different views, you can see our key characteristic top left corner. You can see all the different characteristics of that balloon. I could move the balloon around to organize things if I wanted. Once I'm done with this, I can create a report. And I think this is where we have a pretty unique solution is we give you a few default templates, but what's great is you can customize those templates all based on Excel. So in this case, I'm using a very traditional AS9102 report, and it automatically exports all the information I had in my project, but I can customize those because they're based on Excel. So I could create a new Excel template that have my company logo, some information specific to my company, and because it's all built in Excel, I can have Excel formulas, I can have conditional formatting. It's a little bit hard to see, I apologize, but here I have a formula that says, if it's not within the range of the upper and lower limits, you highlight it in red. If it's within the range, you highlight it in green. And you can do a lot of crazy stuff because, again, Excel is so powerful. Now, this is one piece of the puzzle, right? We went all the way from a 3D part to this. If I wanted to integrate everything into one file, what I can do now is go back to my MBD tab and create my 3D PDF that we talked about before. So now I can create a 3D PDF. I can define my template that I want to use. I'm going to use one of the templates provided by SolidWorks. I'm going to pick the views, my 3D views that I want to have in my template. And at the bottom, I can add files. So I can add a Step 242 file, but I can also add, and this is what we're trying to do from the beginning, I can also add inspection reports so that now I have this 3D PDF, my company logo, all that information. I have a dynamic view of my part that I can rotate, interrogate, measures, and things like that. I have my 3D views, so I can look at all this. And in the attachment, I even have my inspection reports that I can open directly from Adobe. So I can go in the attachment, double click on my inspection reports. I see it, I can fill it, save it, and it will be saved back inside the 3D PDF. So what's nice with all this is you're moving from having a SolidWorks 3D part file, a SolidWorks 2D drawing, a 2D PDF of your 2D drawing with the balloons on it and an Excel spreadsheet, to a 3D file of SolidWorks and a PDF. So bottom line, it's integrated within SolidWorks. It's automatic characteristic extraction. I say simplify revision management is because since we're in SolidWorks, if you were to update the parts, you have a button that lets you update your report as well. And we give you, we give you the ability to simply update it or refuse those changes if you wanted to. And of course, then you can create an Excel report, a 2D PDF, or a 3D PDF. One thing I wanted to mention too is this is a workflow when you are inside SolidWorks. We do offer an application that is external to SolidWorks, a standalone application, simply because we have a lot of customers in the quality control department. They don't necessarily have access to SolidWorks, so they need to have something completely separate. That application also supports 3D file with MBD information on them, and we're working on supporting SolidWorks file with MBD information in the 2020 version of SolidWorks Inspection there. And in the standard application, you can do some other things such as entering measurements, connecting with a CMM machine to importing CMM results and things like that to do directly the color coding of the characteristic in 3D. So I know there was some question at the beginning. Is there anything I can help you with?
I was curious if you've got EPDM. I noticed you were inputting file name and information like that. It would, of course, draw from the data card.
So we didn't have a PDM integration at the beginning. We did add a PDM integration. So I'm not a PDM expert, but my understanding is we support data cards. In this case, what I've done is I just pulled from the parts file custom properties. But especially with the standalone, we also build an integration so that if you update the data card, you update the file property and vice versa. And and other than that, everything is saved within the file in any case. And even if you're using the standalone application, we do keep that child reference. If you create, let's say, an Excel inspection report, we do keep that child reference. Is there another question? Yes?
Is that 3D annotation? Can you change the dimension and go back to update the model?
So when you create your part in 3D, of course, if you change the sketch, for example, that control feature, it will update the PMI. Yes. What you have to do then is re-export your 3D PDF, because it's not bidirectional update. You will have to manually re-export your 3D PDF, and you will have to manually update your inspection report. So you have a button that says Update Your Inspection Project. You just have to click on that, and basically what the software will do is will go through all the annotation again. It will detect a change, and it will let you either accept that change or refuse it, because maybe you don't want to update your report. One thing I want to make it clear, it is not bidirectional. You will have to re-export that Excel spreadsheet. You have to re-export this 3D PDF. So in that case, it's not completely automated. Any other question? Yeah.
What have you been seeing for like crashes when you generate a PDF? In PDM, when we prototype something, it automatically generates a MBD PDF, a 3D PDF, and we seem to get a lot of crashes for that. It doesn't seem to work, and it's kind of a finicky thing. I was wondering what you saw in that nature.
So, I don't have PDM, so I didn't go through this whole scenario. It could be, when you have so many applications interacting, there's sometimes problems. I think the best would be the same as, we do is, if there's a bug, we need to fix it. So I would encourage you to either, get in touch with me or get in touch with your reseller, so that we can, document that and, put it on the pipelines to fix in a service pack. I didn't experience it myself, but I'm sure that can happen. And what I say all the time is if there's a bug, we need to write it down and work on it. Yes?
I think I heard you correctly. You said it supports evolvents as well, evolve symbols.
Yes.
In like an assembly environment, so if you have a large application.
Correct. Yeah. All right. So we saw how you can, again, take your 3D data, put the PMI on it, go all the way to quality control, create those inspection reports quickly. I wanted to show you quickly another example, because that's something a lot of you might have access to without knowing. What we did a few years ago is we added SolidWorks CAM. And if you have a SolidWorks license and subscription, you have access today to SolidWorks CAM. And because we added that application in our portfolio, we also made sure it was working well with all other things. So SolidWorks CAM, is an integrated milling and turning programming solution for CNC machining, and it has some pretty cool stuff such as feature recognition, rule-based machining, torus-based machining. Works for part and assembly, 2.5 axis milling, 3+2 axis milling and turning. If you're interested in knowing more about SolidWorks CAM, before I jump in, I want to mention that we have my colleague Mike Buckley, who is the product manager for SolidWorks CAM. Great guy, know everything about machining. He has a garage for his CNC machines, and he set up a shop floor booth in the partner pavilion where we show this whole process, and we show, you can use SolidWorks CAM to do all that cool stuff. But basically, as I mentioned, it comes in 2 flavors, and one of them is part of your SolidWorks subscription. So if you are under subscription, feel free to take a look at it. The whole point of this solution is, again, leverage your existing 3D data to expedite and streamline the CNC machining. And just to show you a quick video, but before that, point out some of the few things that are pretty unique to SolidWorks CAM. Feature recognition, because it's inside SolidWorks, it will recognize the different features, and based on the template you create, we'll put in place some manufacturing strategy. We also have something that we call tolerance-based machining. The software will be able, of course, to read the tolerances on the different features, and based on those tolerances, apply different manufacturing strategies, again, based on the template you will fill. And what that means is, and what that looks like is, in this particular case, I'm just going through a very simple example, but this is normally the same part. This is normally what we will, something that we will cast and then drill a few holes. So in this case, the first step for me is to select my stock. So I'm selecting the cast part. But if you were starting from an aluminum block or something, you can do that. The next step is to extract the machining features. So it's going to integrate the part, figure out all the different features, and it's going to tell you all the different steps that are needed to basically manufacture the parts. So you can see all those different steps there. And then when you generate the toolpaths, based on the template that you created for your company, you're automatically going to simulate the whole machining, the G-code and all that. And it will point out if there's any issue. It will point out if you need some tools that are not in your tool sets, and things like that. And again, entirely integrated, you can see it's pretty quick. And again, for each of those features that you have to manufacture, it's going to show you all the different tools you need to use. And if you go in your tool set, it's even going to point out the one that you don't have, for example. So all of that, when it's done, you can of course simulate all this, and that might help you figure out some things that could be wrong. So here I'm generating the tools paths, and I can then send that to my machine to actually do the manufacturing. So again, not an expert with SolidWorks CAM. I had to call my colleague to create that quick video. But nevertheless, I just wanted to showcase it to kind of show you what direction we're trying to do. For us, it's, of course, improving SolidWorks release after release, doing a better job in quality and performance and things like that, adding new features, reducing the picks and clicks you have to do your daily job. But we also want to make sure you take advantage of all that intelligence that you build in your model to kind of do all the different steps quicker, regardless if it's visualization, CNC machining, quality control, and all that. It's all part of what we call internally a design to manufacturing strategy, where we try to connect the dots. So again, CAM, you're going to save a ton of time because you saw it. It's pretty quick. It's integrated. You take advantage of being inside SolidWorks, and again, I said that before, easier file management, right? You don't have to have separate file for all those applications. Everything is saved in your SolidWorks 3D part file or 3D assembly file, regardless if it's PMIs with MBD, inspection with SolidWorks Inspection, or this with SolidWorks CAM. And that's just part of our ecosystem. We're very fortunate to have a lot of different partners that help us build comprehensive solutions. If you go in the partner pavilions, there's a lot of them. We have things such as DFM Express and Pro for manufacturability analysis. We have things for tolerance optimization that also run inside SolidWorks and take advantage of the PMI that we'll define in a 3D model. And we even have a company called Origin International that do a software called Checkmate for the CMM inspection that will also take your 3D part with MBD and automatically program a CMM machine to do the actual inspection of the part. So you had a question?
Saving all these extra pieces of
It's a good question. I've not honestly seen that. In a lot of cases, it's not a lot of information. It's mostly text information saved inside the file. And personally, I've not seen that. We did also, I think a year or two ago, did huge improvement into the file size. I think it was with SolidWorks 2018 or 2019 where we did some improvement to reduce the file size because we had customer with assemblies with hundreds of files and it was getting really big and so on, and we did some improvement there, so maybe that offset some of that, but my experience have been that it didn't have any impact. Now, I can't guarantee if you work on crazy complex parts and so on, but the reality today is that your 3D data has most of that information. You have the sketches with the dimension and all that, so in a lot of cases all that information is already there. I could check with my colleague Michael, but yeah, honestly, it's not been my experience. Yeah.
Follow up on that. When you start getting to the next tire assembly, it's not so much just opening a complex file there, but when you're getting into the next tire assembly, now you have 3 or 4 of these with a bunch of embedded MBD. Are you guys seeing anything there? How does it handle that at the next level? I mean, obviously it's hidden, but sometimes when you do stress calculations and things like that, and it's inside of a model and you don't delete some of that and you let it go to the next level, it actually gives performance issues.
So, I mean, generally speaking, when we do surveys with our customers, the two things that come up the most often that, you guys want us to focus on is quality and performance. So I know we have, a lot of improvements year over year with performance, especially with large assemblies with hundreds of different files. So, we work on improving large design reviews and things like that. So, again, not my experience. I don't know how they manage that. I'm sure they can do it in a smart way to not load information that is not needed. Especially when you're at the assembly levels. The same way when you work with large assembly mode, we only load the tessellated geometry and we don't load everything underneath. So I'm sure from a technical standpoint, there's things we are doing or we can do to make sure that doesn't impact your large assemblies and things like that. Any other question? So, I mentioned it's all part of our strategy that we call design to manufacturing internally, helping you connect the dots, go from, conceptual design all the way to production. So we mentioned SolidWorks, MBD, CAM, inspection. There's also composure and visualize. I like to mention those, especially visualize, because again, it's also part of your subscription if you're not aware of it. If you have a license of SolidWorks and subscription, you also get access to that solution. And you can even, it's a separate sign number, so you can give it to somebody else in the company if they need to do rendering and things like that. I think it's always cool to know. Bottom line, that's what we've been trying to do for a couple of years, try to combine all that to help you go from one stage to the other faster, because we recognize it's not just about a pick and a click here. It's not just about adding features, it's about creating an ecosystem where you can go from point A to B in a faster manner. So I mentioned it multiple times, my colleagues. So I'm Matt Forkett, I'm responsible for inspection. My colleague Obowu, I'm sure you heard about him or you saw him before, he's been responsible for MBD product line for the last 4 years. And my colleague Michael Buckley is responsible for CAM. I would encourage you to reach out to those guys if you have, deeper questions or if you want to know more, about how those solutions can help your businesses. They are generally at the partner pavilion. And in any case, if you have particular question, I can also reroute those to you. And I know they've been presenting as well at SOLIDWORKS World. So, one thing to keep in mind is you can always, in a couple of months, all those presentations we put online. And you can re-watch them. So if there's some great breakout session you wanted to get to and you couldn't, they are also available as well. All right. Thank you very much. Yes?
The SolidWorks MBD and SolidWorks Inspection, are those additional cost add-ins?
Yes.
Yeah, SolidWorks Professional, you would pay extra for that?
Correct. Yeah, the additional products.
Do they come as a package or you buy them separately?
You each buy them separately. Here's a question. So we have a lot of time left. So in any case, if you want to come closer and if you want to talk about specific needs that you have, I'll be staying here for a while. So don't hesitate.